Hello everyone, welcome back to the Avalon Game Project. So last time we have implemented the quest voting state, and today we're gonna implement the very last state, the game end. Game setup, game end. I almost want to rename this to setup. Game setup, well, definitely don't like the name game end. It should be end game. Actually, you know what? I'm gonna change it. End game sounds better. Do. Okay, we have end game state. So let's go implement it. Cool. So in the state, we first add one. We call it. Oh no, I already have a game end. Nope, I'm gonna change it to end game. Oh, right. We have to refactor it. End game. And of course, the text should change too. Okay, so let's implement. Game end state. No, refactor this to end game state. And change this to end game state. Okay, so let's turn on. Oh, it's still on. Nice. Okay, so which one failed? Rewrite. So, oh, God, no, sorry. We should just, okay, let's rerun this. Now things pass. We should just do refactor and call this end game state. And now things are still passing. Cool. So now, as usual, we're going to do TDD. So let's create a test and write test while writing our state. So test end game state. Add to git, of course, and let's split this, and we have end game state. Okay, cool. So first of all, it has no next state, so we don't even. So this is an end state, so we are not going to. So the handle is not going to return anything, or actually. So we really should go here and refactor this. So this, oh no. Refactor, change signature. It should return optional self. Why is optional? Because why is it optional? Because for the end game state, it's not going to return anything, and that should be an indication to the state machine that it has reached to the to a final state. Another thing we could do potentially is to okay, I'm debating. So we can do two things. First of all, we could do something like this and return a none. So basically return an empty value to return value to represent that we have reached the final state. Or we could potentially create two fixed states. One is the beginning. start state and end state, so that we could use that. So for example, for the start state, we could simply just return the very first state, then we know where to start, and the very last state could return an end state for us to know that it has ended. But the more I think about it, the more I realize that to have those two states might be over engineering for our use case. Because let's face it, we only have 1, 2, 3, 4, 5, 6 states. And this is not a published library, it is the core of the game. We don't really need such a complicated mechanism for representing 6 states. So I think for now I'm okay with none, because the city machine could just verify that, okay, if current state.handle is none, we're not going to do anything. Okay, so in this case, we decide not to do anything, and we have changed the signature, and I am going to open the EndGameState and start implementing it. So first of all, it has no next state, so that's good. So all we need to do, so this doesn't even accept a next state parameter. So one less thing for us, one less fixture to add in the tests. So first of all, we could just simply start def test endgame state. Yeah, we have absolutely nothing to depend on. Oh God, what is this? So the state equals to EndGameState. We're going to import this, and when state.handle, we have an event, but we're not going to implement anything. Then assert state.name equals to state name.endgame. Let's import this and see if tests are still passing. Cool, wonderful, it's still passing. So in the endgame, we're gonna do a couple of things. Transitions from quest voting state yeah, so this is the end state. This is end state, so we transitions to nowhere. Handles I think 2 events. No, actually only one. It handles the assassination target submitted. Actually, let's go add this event name, event type, assassination target submitted. Okay, so this is the event type. With that, wait, let's do it properly. State assassins. Okay, submitted event. What does it do? Broadcast broadcast assassination started, pending for the assassin to pick a target. Reveal the target broadcast assassin picked a target. Cast the target of the assassin picked. The assassin picked a target. Let's do it. Assassin picked a target. And then if the assassination attempts exhausted, reveal every broadcast everyone's row and the game result. Okay, so it does a couple of things. Let's think about it. So I think the broadcast everyone's row and the game result should be on exit. So def on exit, game ID string returns none. On exit, what we're gonna do? So I think broadcast everybody's row and the game result should be the responsibility of the game service, right? So let's do that. Service, game service. Do we have a game service now? Yes, we do. So let's import this and have a self.gameService equals to game service. With that, I wonder if broadcast everybody's row should be the responsibility of the player service or the game service. Debating. So let's put in a game service first. Let's call this method broadcast game result. Is it just game result? Yeah, we can call it game result. Yeah, it's fine. Yeah, potentially I think it may or may not. So we may or may not add a new method called broadcast everybody's row, but I think this can be included in the same message. So at this, so on enter we do not know yet. So yeah, here is the problem. So the problem is EndGameState might just be, it might or might not. rely on an event. So here is the problem. How can we allow a state to automatically transit into a different state? So we can play with onEnter maybe. So if on enter, we realize that there's no assassination attempts, what we can do is to so we could potentially let onEnter to return an event, so that if onEnter returns an event, so if there's absolutely if we do nothing with onEnter, it returns self. But if we do, it can. So onEnter might. No, that's not good. I don't like it. Okay, what can we do about it? Broadcast handle. So if we do it in the onEnter, we could call the handle method ourselves, but then the state machine wouldn't know. So the state machine would, what I imagine the state machine would do is to get a new state, calls onEnter, then just exit. So the next time when the state machine receives an event, it would pass the event to the current state's handle method and get the next state, and compare the current. If the current state equals to the next state, it does nothing, and if it isn't equal to the current state, it would call onExit and call the onEnter of next state. So in this case, I think we must do something with the onEnter method. Okay, onEnter, I think we could do this. Okay. Okay, so we have this. This should return an int value. So if it equals 0, then let's just call onExit. And return. So I myself hate if else, so this is just a I prefer this. So let's handle all the to say edge cases first, and do an early return. Then we just sorry, then we just do the happy path, the actual logic. I think I like this. Okay, so it would so if not, then it broadcast the assassination started, and it should actually, you know what, I think this one method is good enough. I almost want to call it on enter endgame state, so that we could actually associate the game service implementation with end state. So if we were to do this, let's go back and take a look at the quest voting. So in this case, what we could do is, well, this really should be on mission vote casted, and we simply just go get the event instead of doing the validation here. Yeah, I think I'm going to, so, and on enter, instead of doing two of these, I think I'll combine these two to a on enter quest voting state. Then we would leave the more detailed implementation to more detailed implementation to the mission service. Yes, I think I'm going to do that. So we are going to do some refactoring next time. So yeah, let's go. The end game state. Okay, so not this. On enter end game state. So we do not need. Do we still need these? We need broadcast game results. We do need to get assassination attempts. Actually, no, this shouldn't be like this. It really should be handle. Oh no, it's no, actually it's I'll enter in-game state. So it's fine because these services are only exposed to the state machine. So I think that's good. So instead of broadcast game result, I am going to rename it to onExit EndGameState. We still need this get assassination attempts because I think this kind of logic must be implemented here. Okay, so let's do some tests. Test game state. We need a fixture. Okay. And we want to test EndGameState on enter game service. We still need this. Oh, we need to give it game service. Okay, so state on enter, we want to know that the get assassination attempts. Oh, right. So when we get in, we want to verify two things. First, to verify two branches. First, if the assassination attempt is 0 or it is not 0. So we have to mark the game service dot get assassination attempts dot return value equals to 1. So in this case, we still have assassination attempts. So then the game service dot on enter EndGameState is called, but game service dot on exit EndGameState assert not called. Right. So we have this, and the tests should pass. And I'll enter with assassination attempts. So now we want to without assassination left. So in this, instead of 1, we return 0. So now on enter, we want to verify. Actually, I forgot to verify one thing. So the get assassination attempts should be assert called once with on enter. Oh shoot. So we'll have to get a game ID equals to game ID, and on enter we are actually going to call it with that. And the assassination attempts should be called with game ID as well. And same here, game ID equals to game ID. and enter is called with not game service but game ID. This is proper way of calling, and the end game state should be on enter assert not called, but on exit assert called was with game ID. Okay, so now the all tests passed. We have verified the on enter and on exit. Let's think about the actual implementation. Oh, let's first add the validation. So if event.type is does not equal to event type.assassination submitted, we raise a value error, of course, and we want to add a test case against it with invalid event. So the invalid event equals to event. Here I just want to go steal some previous tests event definition. I'll just steal this one. Oh, invalid event type, perfect. So we have this now. Let's format this, import event. The event type is still the blamed quest started. So when we do state.handle, we expect that it would raise an exception. Meanwhile, if no, this should not be broadcast assassination started, but rather on assassination target submitted event. But it would definitely not just have a game ID. Again, we I mentioned I would like to introduce a validation package, but I haven't get to that, so let's just copy paste whatever we have with another to do. We have round voting quest voting strategy. We will get these. I cannot stress this enough. I am not going to. I'm strongly against copy pasting code. I do not like to research on packages while I'm recording. So I will do that offline and just to remove this very naive implementation altogether. So why they don't like this? Oh, okay. So we definitely don't need a mission number anymore. Oh, we need player ID. For verifying Okay. So here we needed to have, we don't need this mission number anymore because there is no mission. So we have a player ID and we have a target ID. So the target ID should just be target ID. And the on assassin target event. We should get. I'm actually thinking, should we just pass the event in? Because it literally says submit event. In this case, we do not need to worry about the validation, and the validation could be pushed down to the service. The only problem now is if the state machine is the place to validate the event. I think, well, we do validate the event, but I think the payload should be pushed down to the service. So I'm going to just pass in the event, and now I think this, by doing this, I think it makes it extremely clear that so look at this. I think it's but by just looking at this this piece of code, I think it is safe to say that the logic is very clear. So on enter, if we do not have any assassination attempts left, we're just going to call on exit and be done with it. If we do have some left, then we'll call the still call the on-game service on enter EndGameState. The implementation, the state machine doesn't care. It let the game service know it has we are on the on enter hook, and the rest is handled by the game service. Same as on exit, let it know we're in the on exit hook, and the game service will take care of everything left. Well, in the handle method, we do want to verify if we're getting the right event type, and if we're getting the incorrect event type, we're going to throw an error explaining that we're only expecting this particular event, but we got something else. And after that, the game service could handle the event. So I think I would just rename this again to call it handle assassination target submitted, and this, instead of game ID, I would ask it to accept an event. Okay, so in this case, our endgame state is extremely clear. We do not need to write that much of a validation tests for this particular method. So now we have verified the invalid event, and now with a valid event, the event would be this, and the payload. So actually I would rather to have this event to be in a fixture, because if we do need So if we do need another test which requires a valid event, we could just pull in this fixture. But this would make this less clear, yes. You know what? I try to remind myself, do not over-engineer. So this is the moment I'm teaching myself that let's not fix things unless we absolutely need them. Let's not overcomplicate things. So if we do not need this event, let's not do it for now. Let's define the payload here. Actually, we don't need a payload because all we need is the event with a proper type. So now the handle actually should okay. So what we're doing now is that after handling the handling the assassination target submitted event, we still want to verify if we have any assassination attempts left. So, and if we do, we just want to return ourselves and not call the onExit at the moment. But if it is 0, we return none and let the state machine know that we have reached to the end. So now this creates 2 branches which we need to test. Next state equals to handle event. So I think I'll rename this method to with assassination attempts left. So now we will have to mock the game service so that the return value should equal to 1, yes. And with this, we would verify that the assert next state is actually ourselves, and we want to know that the game service dot get assassination attempts assert called once with event.gameID. So the test should pass now. Service get assassination attempts. So assert none. What? Oh, right. Crosshair habit. Now it should pass. Yes. And we also want to verify that the game service dot handle assigner submitted handled called once with event. Yes. Okay, now let's copy paste the whole thing. Without anything left. So in this case, the return value should be 0. And the next state is none. The next state is none. So let's not do this to pollute things. So the handle assigner submitted should also be called event. This get assassination attempt should be called by game ID. So this part of logic is the same. It only affects the return value. So our tests should all pass now. Yeah, I think this is pretty much it. I think I'm really glad that finally we have, so little by little we have iterated on how to design a proper state and how much abstraction, which logic should be in the state class and which logic should be pushed down to the service. I think this is a great example, and tomorrow we are going to use this example, use the EndGameState as an example to refactor the previous states so that we have a very clear cut of responsibilities and a more standardized function naming. Cool. Yeah, I'm really happy with this. So yeah, I'm gonna, only problem. Okay, so look at those little green checks. So we're gonna stop here, and yeah, so next time, bye.